Hey, everybody, welcome back. Hope everyone had a great lunch. I'm here. It's not lunchtime for us, unfortunately, being in the United States. It's breakfast time, but I'm here with Tejas, a senior software engineer from Netflix, who's here to tell us about cloud microservices for the next billion. I cannot wait to hear it as an avid consumer of Netflix. So, with that,
Yes. Hi, everyone. Today I'll be talking about cloud microservices for the next billion. The agenda for my talk is as follows. I will go over a brief introduction about myself. We'll go over the problem space definition, and then we'll go about defining the requirements and what exactly were we trying to solve there, and how did we come about ideating a solution for it. Some of the design choices that were made along the way, and how agile practices and designing iteratively really helped us in this journey. Finally, there'll be some results and takeaways that I've gained from this experience. A brief introduction about myself. I began my journey in the year 2010 when I graduated from Carnegie Mellon University in Pittsburgh with a master's in electrical and computer engineering. From 2012 to 2016, I worked at companies such as Apple and Samsung, where I was working on distributed systems. In the year 2016, I joined a startup as a first hire, and we were trying to build a marketplace for FMCG. FMCG is fast moving consumer goods, and I'll get into exactly what these mean. But we really wanted to build an Amazon where you have buyers and sellers, and there's a marketplace for it. The goal was to build software for the masses. And the scale of it is something that I'll explain as well. This talk actually focuses a lot on my journey as the first hire at that startup. After that, I joined Datrium and Box, where I was working on distributed file systems, storage, cloud, replication. And finally, I've been a part of Netflix for the past year and a half. I work on the data storage platform side, where my job is to architect infrastructure solutions to support Netflix movie creation process. So when artists create movies, they have to share these assets with artists that are sitting around the world. And so if you have to build infrastructure which is a mix of cloud and on-premise for such use cases, that is something that I work on and I develop at Netflix, which again serves a billion people. But this talk is more focused on the marketplace side of things, which and the design practices that I adhere to there. Now let us get into problem space definition. Like I said, the problem space that I was dealing with was fast moving consumer goods. These are packaged goods, beverages, food items, cosmetics, etc. In India, you find towns and cities that are littered with millions of these mom and pop shops. So they are small and medium enterprises compared to the Macy's and the Targets that you find in the US. The market cap for this industry is $50 billion per year. In the traditional sense, the buyers are retail shop owners and the sellers are wholesale traders. As you can see, there are just 0.33 million wholesale traders for 12 million retail shop owners. So there is a many to one relationship in such cases. What I observed was that there is a lot of food wastage in this space. So if we can create a dent in this space using technology, we can avoid food wastage. There are several reasons for the wastage as well. Firstly, the last mile delivery is very untimely. And this is the delivery from the wholesale trader to the retail shop owner's location. It results in wastage of perishable items. There is no feedback mechanism from the buyer to the seller, and there is no good way to capture feedback from the end users of the product as well. And there is no good way of maintaining a catalog of items that are present in a store at any point in time. So this too results in a lot of wastage of perishable items. Finally, there are deeply entrenched relationships between buyers and sellers. So buyers do not have the means to explore other sellers or around them and maybe seek better offers from them. Together, India is a market of more than a billion people. So the retail shop owners actually serve a population of more than a billion. So if you create a dent in this space and if you introduce technology, which is not really present in this space, you can actually impact the lives of a billion people. And that's how you are building microservices for a billion people. So what if we could prevent this food loss? What if we could create a marketplace like Amazon for FMCG products, which does not currently exist for SMEs in India? In this case, the buyers would be your retail shop owners and the sellers would be your wholesale traders. What this gives is buyers a choice and sellers a platform to reach out to other buyers. Choice is good because it means that buyers can now uncover better deals and timely deliveries, better user experience. There is also an opportunity to have feedback mechanism from the end customer to the seller, which is missing today. There is buyers will have the ability to search and seek better offers and can provide those savings back to the consumers, which results in saving money. And shipping, which has been one of the banes of this industry, will be handled by us. So we will take care of getting the goods from the wholesale traders to the retail shop owners. And in this industry, almost all the orders are bulk orders, which is great because they are cost amortized when it comes to shipping. Uh, Finally, since we are attacking a domain where the users are not very tech savvy, it is important to build an empathetic user experience from the ground up. And this is something that I focused on. And technologies such as Amazon, like AWS software, Elasticsearch, Kafka, all of them came to my rescue when designing such services. Now, when you think about our users, they have never used a smartphone before. So they actually are very well versed with feature phones. So when you think about someone that has not used a smartphone, what are some of the challenges that they can come across with when they're using your software? Uh, they have to do with the fact that their concern is mostly around the battery life of the phone that they're using. So you need to design software that does not drain a lot of battery. This includes like both the amount of data that you store on the phone as well as the network connections that you make to cloud to retrieve the data. The second part is that a lot of the users were not very well versed with English as their first language. So you had to actually you had to actually show the images in local languages, which means that the products had to really you need to localize the products that are being shown on the application as well. The concepts of cart, order history, order tracking were missing. So they did not know what a cart is. And we tried our best to educate them. And I'll explain how we actually were able to still work around it with our users. And there were many other challenges. Product images is a great one. So typically, when you look at anything that you see on Amazon, you read a lot about the product attributes, features of the product, size, width, all of that. But in this industry, they have to quickly make orders. So they actually just rely on huge images of products and they don't try to process the attributes of the product. So for them, if something on the shelf, which is orange in color, has been bought by a customer, I need to place an order for that with the wholesale trader. So they will just quickly find that and just swipe and place the order. They don't really get into the details of trying to understand a lot of the attributes of the product as well. The second step is defining the requirements after we've addressed what the challenges would be. So when you think about a marketplace, what are some of the table stakes for it? The first thing is product search, the ability to search for products, browsing products, and looking at different images of the product and the different variants of it. Ability to add items to a cart and just place an order in general, the entire flow of it. And this includes looking at your order history. Authentication, authorization, notification, ability to sift through different offers and sift through different sellers. And finally, on the other end, having a seller portal where a seller can also ingest products and offers, view the orders that are placed, generate invoices, all of that. So to build these table stake requirements, there were some initial design choices that I made. I went with AWS and decided to go cloud native. Cloud provides ease of scale, ease of manageability, pay per use, and is ideal for bootstrapping any idea. I leveraged DynamoDB. DynamoDB is a NoSQL database. In this FMCG product domain, data is very unstructured initially. So I did not have the means to explore a SQL database for this. NoSQL database served my purpose initially, and this was used to represent products, orders, notifications, shipments, and other tables. I dabbled between using Kinesis and Kafka, and they were used for event handling and asynchronous processing to power the downstream services that are leveraged, such as Elasticsearch and other Redshift data warehouse. They are used for asynchronous processing, for building the browse and search capability, and also for capturing metrics. Finally, like I said, we wanted to capture metrics, and we needed a way to get customer insights. For example, what are the products that the customers are ordering in bulk in the month of March, or which products get ordered together more frequently, or how does the seasonality affect the products that are being ordered. So that helps our sellers procure these items in advance. And so we had to capture those metrics, and we use Redshift, which has a very nice integration with DynamoDB and Kinesis to save the metrics as well. So whenever you are designing any software, you think about think deeply about a problem and architect it pretty well to solve any use case. But implementation can always be iterative in nature. So if you want to get from point A to point B, if you require a airplane to go there, instead of investing in building the tire of the plane, let's first build a bike. That's the approach that any software that I've seen in my career has taken, any great software. So I tried to use those principles and use the agile practices in this case as well. So I started off with a brief pilot just to see the market fit. The pilot was a very simple one. It was an SMS-based solution. My users were very well versed with feature phones, so SMS worked very well for them. Every morning, they would get an SMS that contained a list of all the products and their prices. And they would respond by the end of the day with an SMS that contains whichever product they wanted and what was the quantity that they wanted, right? So this works well if you have 10 customers, because you need a human to vet the responses on the other side. But as soon as your customer base grows, you cannot really scale this solution. All we wanted was the ability to see if there is a use and a market fit for what we are providing. And the backend was very simple to develop in this case. We used Lambda to send the SMS. The SMS was generated from a DynamoDB table. At the end of the day, when the human was vetting the response, they would update the DynamoDB table again. And finally, we would place the shipments and get the orders. As you can imagine, this will not scale pretty well, but even with this basic bare bones solution, we saw that we were getting $500 revenue per day, which wasn't bad. So there was a market fit. And then we pivoted to the next solution, which was introducing, instead of just sending an SMS, we had an Android app, and we introduced smartphones to our customers. And the look and the feel of the app was such that it had the same feature set as the feature phone. So it still had a list of products which they were well versed with in the SMS world. In this case, we decided that we would split the seller portal from the buyer's application. So seller portal was running on an EC2 machine. The buyer's app was really calling a Lambda on order placement. And this Lambda would do the same thing. It would just mutate the DynamoDB table. But in this case, there is no human vetting required, because when the portal, the app would actually show the list of products as soon as they were introduced in DynamoDB. So that code we developed. This works great for less than $500 per day, 500 orders per day. It only works for single orders. So there's no concept of cart introduced at this point in time. Fun learning, Lambda has a very slow warm-up time. So order placement was very slow in this case. So we then moved to the next part, which is we replaced Lambdas with a monolithic service. We had now two monolithic services, one for the sellers and one for the buyers. They would interact with multiple tables on the backend, like product, order management system, notification, authentication, invoices. The framework that I used to develop these was Drop Wizard. There is no browse or search capability at this point in time. So the buyer would scroll down to find a product. And in that case, once the product was found, they would just swipe right to place an order. So there was no cart as well. I also introduced localization at this point in time, which means that the product images contained local languages. And I also did not have any relationship models, which means that which brands, which products belong to a particular brand, or which brands are under a manufacturer. All of those relationship modeling has not yet been done. It is just a list of products that the buyers can see at this point in time. Finally, we moved from a monolithic service to microservices. Monolithic services are difficult to scale, modify, test, and release. They interact with multiple databases, and there is a mixing of business logic. So there is no clear separation of concerns in monolithic world. So the right way to go about scaling any monolith is to split it into microservices. But it is more of an art than a science, really, because at the very end of the spectrum, you can have each table have CRUD APIs around it and make it a microservice. But now you are actually introducing more problems, because to return a single response to an API, you may actually end up contacting tens of microservices on the backend. Now that increases your latency. That also increases the permutation of network connections that you have to maintain between these microservices. So the right way to go about it is to see which microservices or which entities can live and die together and have the same life cycle, and try to put them into a microservice. So similar functionality can live in a microservice instead of each table having its own microservice. And that is something that I explored in this phase of development as well. The other interesting part, if you see here, is that we now have DynamoDB, and we have downstream services being powered by it. So whenever you update a table, today we have a well-known name for something like this, which is change data capture. What that means is that when you mutate a table, whatever is the mutation that you did, that is captured in an event, and you can process that event, and that can be used to power downstream services. So let's say you ingested a product and you want to show that product on your app at that point. So ingestion of a product would add a line, add a row to the DynamoDB table. But that row addition can also trigger other downstream services, which in this case is catalog indexer, that can actually do the heavy lifting of showing the product on the app. That can happen asynchronously. So this is a very common paradigm of software development that is being employed at multiple places. In order to capture this, we actually use Kinesis initially. Kinesis comes with an integration with DynamoDB, where it can capture DynamoDB streams. And I wrote indexers for the downstream services. So I wrote a Redshift indexer, which would capture the metrics and the clicks of the users and index Redshift tables. I wrote an Elasticsearch indexer, which would capture product information and then power Elasticsearch clusters that are used for browse and search, which I'll get into as well. And finally, we had the catalog indexer, which would just show the product on the app. I use Drop Wizard for cloud native microservices. Drop Wizard is a framework that contains Jackson, Jetty, Jersey. Jetty is an HTTP server inside the main method. Jersey maps your REST requests to Java objects, and Jackson is used for JSON serialization and deserialization. It's very simple to write a microservice using Drop Wizard. This is an example of a simple hello world service. As you can see here, you just have to specify the path, what is the content type that it produces, and have your method with appropriate annotations, such as in this case, get method, and we are timing it, which takes in a query parameter of a name, and we can return the response appropriately. Now, I could have used Spring Boot as well, because it's another alternative to develop microservices. The dependency injection comes built in Spring Boot. So that is another plus of using Spring Boot. The number of lines of code that you have is much less. And lesser lines of code implies lesser bugs. So that would have been also another choice. But I just picked Drop Wizard because that was the first search result that came in at that point in time. So now getting into the interesting part of this domain, right? And when you look at things around you, for example, the iPhone, right? You know that the manufacturer of the iPhone is Apple. The brand is iPhone. The product vertical is smartphones. The product line is iPhone 12, for example. And the product itself is your iPhone 12 with an IMEA number, which is unique to your phone. But for fast-moving consumer goods, these attributes are not always clearly spelled out. If you look at this image, for Procter & Gamble products. Some of them you may be able to recognize. The product lines here are diapers, kitchen towels. The brands are Tide, Ariel. The product verticals are baby, feminine care, family. And finally, the products are Bounty, kitchen towels, 33% extra. So, like, as you can imagine, for a lot of such products, instead of a tree of relationships, there's really a graph of relationships. And that is very difficult to model if you use traditional database schemas. So in order to give the users to have the ability to search any product, there must be a way to get to the product. Our biggest challenge was that because relationships between these attributes are very dynamic in nature, how do we build a backend store to serve the complex nature of queries? We needed the ability for the users to search a product by brand or by manufacturer. Some of the sample queries are, give me all the products that belong to a manufacturer and a brand. Give me all the products that belong to a product vertical, or give me all the products that belong to a product line and a brand. And to model this, I used Elasticsearch. With Elasticsearch, you can build an index and relationships that can help serve complex queries with extremely low latencies. You can get features such as autocomplete right off the bat as well. And this is something that I leveraged a lot with our customers. So whenever a product is ingested into the DynamoDB, we would actually ask the users that are, or the sellers that are ingesting the product, to also include brand, manufacturer, or whatever information they have. This would power our downstream services, and we would have appropriate indexes for a brand updated with that product information. So a query that comes from the customer to give all the products for a given brand would just serve all the products under the brand to the users. And for every product, we would actually highlight which are the interesting attributes for it. Because if someone orders a product, we wanted to show all the products that belong to the same product vertical sometimes, but all the products that belong to the same brand other times. So all of those were learnings that we had from our interactions with customers. So when they ordered rice, we had to show products that belonged in the same product vertical, but could span across brands. But if they ordered, let's say, biscuits, we would show the same like products under the same product brand, but not the same vertical. So it's like there's a lot of conversations that we had to undergo with our customers to understand what they expect to see when they order something. State of the app at this juncture. So we had the buyer's app, which had product search and browse. Buyers could place an order in a cart and order. There was an order management system and an order history that they could look at. On the seller side, we had a portal where they could ingest new products, update the quantities, update offers, could generate orders and invoices as well. Some results and takeaways from this learning. On the technical side, right? DynamoDB is not the best database for relationships, especially when it comes to graph kind of relationships. I should have used a graph database such as Amazon Neptune or a Neo4j that is backed by DynamoDB. The reason I went with DynamoDB was because it had DynamoDB streams, which was change data capture. But if you can build Neo4j on top of DynamoDB, you can still leverage the streams events, and it makes the job of your indexer simple as well. Kinesis is another alternative that I picked. And Kinesis was because it came built in with Amazon, but Kafka actually allows for faster retrieve and stores data for longer. Kinesis, I believe, has a 7-day retention at the max, or at least back in 2016, it had 7 days retention. Now, Kafka also has connectors for DynamoDB, Redshift, Elasticsearch. So it's pretty like widely used in the industry. The only challenge would be it would be managed by us. So we'd have to take care of, managing the cluster, scaling it up, and then it's not managed by AWS. So that is another thing that we have to be mindful of. The third aspect was containerization. So it's a very common theme these days to use Docker and Kubernetes for rolling deployments on cloud. I did not explore using them at that point in time. CI/CD pipelines that could help trigger Jenkins jobs, and Spinnaker that can be used to deploy and monitor these apps in cloud would be something that I would have explored at that point in time. Also, because I have so many microservices, the use of service mesh, that service mesh is nothing but it allows you to peek into the network connections between your microservices, and you can build a lot of insights on top of that. It can tell you the health of your microservices. It can tell you what kind of responses or what's the latency of these microservices. And you can build in some ways a call graph of which microservice is talking to which other microservice. So that helps debuggability as well. And so service mesh can be a very great candidate to be used when you have multiple microservices that you're dealing with in your system. On the product side of things, I realized that my customers were not using cart a lot, even though I had the cart functionality, because they were not very well versed with cart. And they would just swipe right to place the order because that was the functionality I introduced for simple placement of orders. So they would do that multiple times during the day. What was happening was every time they would do that, it would create a separate order entity on the backend, and they would pay shipping costs each time. So I wanted to save them money. So what I did was I actually had a virtual cart on the backend, which would collect all of these items that are placed throughout the day and put it in one order cart. That resulted in 27% savings in shipping costs for my customers. I focused a lot on enhanced searchability. Products have missing data. Some of them have missing brand or manufacturer. So I did a research per product to ingest appropriate values that were driven by customer interactions. That led to an enhanced connections between products, an increase in our searchability and orders by 24%. And we invested a lot in Redshift. Redshift is very expensive. So but we were mindful that we wanted it to be a first-class citizen of our architecture because we wanted to capture insights and metrics. And that was another business opportunity for us, to be honest. So we helped our sellers by capturing these insights and presenting it to our sellers. And that led to a 34% increase in revenue for our sellers as well. But like I said, Redshift is expensive. Our cloud costs exploded from $500 per month to like $4,500 per month within the first 6 months. The results and the takeaways. We went from 1 to 7 wholesale stores in the first 6 months, 10 to 400 retail stores. Our insights grew from 7,000 points per second to 780,000 points per second. Revenue grew from $200 per day to like $8,000 per day. And finally, we were able to save 27% food wastage. So we reduced the food wastage by 27% by having this entire architecture built. Some of my takeaways from this journey. You build software for the customer. You need to show empathy. You cannot apply the same principles that work in one industry to another industry without understanding what the customers are really looking for. So when you're building software, interact with your final customer, try to understand how they are viewing technology and see if you can educate them. But if not, try to build things that they can use easily. More code is more bugs. There is a common adage that there's a bug every 100 lines of code. So best way to reduce your bugs is to write less code to do the same task. Ability to write simple and lucid code goes a long way when you're developing distributed systems. There are pains of scale. When you scale, things will fail. But you need to be mindful of what can fail, and you need to design systems that fail safe. At no point in time should you lose data. It's okay for a product image to not show up, but it is not okay for a customer placed order to not show up. Performance on smartphones is very critical in this industry. So using software, developing software that does compression, encryption, and deduplication of data on the smartphone and reducing the cloud footprint of the data was another very critical aspect of our development and something that I invested in. Invest in learning about the business and the pain points and see if technology can solve some of them. For example, in our case, like they did not have a catalog that they maintained at their store, but it is something that is very easy to build on top of your order history, because your catalog is nothing but a list of your order histories that are compacted. So we were able to provide them that adjacent to our offering just to make their lives easy. and because they had a pain point in that. Data is gold. Invest in gathering insights from data. Invest in having the correct mechanics in place to capture metrics as much as you can. In the initial stages, capture everything. Then become mindful about it and like filter whatever you need. But when you're starting out, you don't know what you know and what you don't know. So it's important to capture whatever is out there. We captured every click of the user, like everything that the user did on the application. Cloud costs will spiral out of hand if not designed correctly. So you have to design intelligently for the cloud. This means leveraging a mix of on-premise and cloud solutions to reduce your costs. And because you're building an app that is cloud native, you sometimes will have to then explore different cloud providers, their egress costs, ingress costs, and build software that is cloud agnostic as well. So don't tie yourself into cloud technologies because then you cannot move away from them to a different cloud provider. That was my learning with Kinesis. And that's why I wanted to explore Kafka for that use case. Use generic software that can work across different cloud providers and across on-premise software as well, systems as well. That's my time. Thank you so much. Please feel free to reach out to me on LinkedIn, Twitter, and email address if you'd like to learn more about my journey. I'll just put a plug in here. Netflix is hiring. So if you're in the US, please feel free to reach out to me for positions in Netflix. Thank you.
I'm just checking to see if we have any questions from the audience here. In the interim, though, I had a question on you about all this. You know, it sounds like you had, at least at the start, the cloud costs for what, even though the architecture is pretty sophisticated, were relatively minimal. It sounds like when you were building all this out, like that flexibility was pretty key for you, wasn't it? I mean, did you run into did you really pick the technologies based on the cost, or did you just pick them for the technology fit when you were building it out?
I picked them on the ease, not on the cost part of it. So DynamoDB was easy because it was NoSQL database, had DynamoDB stream. So I did not have to write a lot of code for getting the change data capture. And it meant that I could roll it out sooner and get feedback from my users sooner. So I started out with that. But then, when you realize that as you scale, some things may not just work because you have a limit on the number of put requests that you can do, all of that. So then you also realize that there's some structure to your data. It's not as unstructured as you thought. So those are great points when you can actually lift and shift from DynamoDB to a SQL database. And I think that this comes in every startup's journey. I've seen this model being rinsed and repeated in different companies that I've worked with. What one must be mindful of is that if they can, they should invest in trying to understand their data beforehand and pick services so that your lift and shift is limited and it's not spawning across all the domains that you've architected.
All right. Thank you so much. I appreciate it.
Yep.
Well, thanks, everybody. I think we'll go ahead and cut to break here. Tejas, thank you so much for your time.
Sure.
And everybody, we'll see you here in just a little bit.
Thanks, Bill.